All right, today we're going to look at 10.3 day 2. So we're going to continue solving radical equations. We're going to look at kind of just the next two situations that can happen and how we would solve those. So first thing we want to go over is what an extraneous solution is. And an extraneous solution is a solution of a transformed equation that is not a solution of the original equation. So kind of what that means is when we're solving these, we are going to be squaring both sides of the equation. And in doing that, we could potentially get an answer that seems like it's correct, but when we check it with the original equation, it's not actually correct. So we won't necessarily know that that's happening until we go back and check our answer. So we want to make sure that we're just always checking the answers that we get at the end and making sure that they do indeed work. So to solve these equations, we want to make sure that we have one quantity on one side and one quantity on the other. In some on your homework, you'll have something like 4x root 4x minus 5 equals 0. So you want to add 5 to both sides. So you have one quantity on the left and then one quantity on the right. Okay. Once you have that set up, you can go ahead and square both sides of your equation. So in A, that'll leave us with just 4x minus 12 equals x plus 3. And then you can solve the equation pretty much like normal. Add 12 to both sides. We have 3x equals 15, so x would be 5. And then we want to make sure that this is not an extraneous solution, so we're just going to go ahead and plug it in. So we would have 4 times 5 minus 12, and we want to check if that's equal to the other side. So 5 plus 3, okay? And I'm just taking the original equation and substituting 5 in for x. So this would be 20 minus 12, so that'd be root 8, and then 5 plus 3 is root 8. So these are equal, so I'm confident that x equals 5 is correct, and it is not an extraneous solution. All right, example B is really similar. Again, we have one quantity on the left and one quantity on the right, so we can go ahead and square both sides. So we'll have 3x minus 17 equals x plus 21. And then we can solve the equation for x. So we would get x is 19. And again, we want to just substitute that in. So we would have 3 times 19 minus 17. Is that equal to square root of 19 plus 21? All right, so 19 plus 21 gives us 40. 3 times 19 is 57. Minus 17 would also be 40. So we get root 40 on both sides. So we're confident that x equals 19 is correct. All right, the next two examples are going to add in a little bit more difficulty. So again, on the left-hand side, we have root 6 minus x, so we have one quantity. On the right-hand side, we have the other quantity x. We are going to go ahead and square both sides. So on the left-hand side, we're left with x minus 6. On the right-hand side, we're left with x squared. And this is where we're going to tie in what we learned in the last unit. So we have a quadratic equation, and we need to solve it. So what we want to do is we want to move everything to one side of the equation, and we need to use one of the methods for solving quadratics. So remember, we had a lot of them. We had factoring, we had the quadratic formula, we had completing the square, we had graphing. For this one, I'm going to always go to factoring if that is possible and easy. So what I'm going to do is I'm going to say, okay, what multiplies to negative 6 and adds up to positive 1? Well, if I do x plus 3 and x minus 2, right, when I multiply those, I get the negative 6. And when I multiply these, we get 3x and negative 2x, which would give us that positive x. So this one's pretty easily factorable. And so that's the method I'm going to choose. And then we're going to apply the zero product property. So we get two answers, x equals negative 3 and x equals 2. All right, this is going to be especially important that we look for extraneous solutions. So when we go back to the original equation, if we try 2, we would have 6 minus 2 equals 2. Well, that would be root 4 equals 2, which is true. So that works. When we go to check -3, we would have 6 minus -3 equals -3. Well, the square root of 9 does not equal -3, it equals +3. So this is an extraneous solution. It is a solution to this equation, but not to our original. So we're going to eliminate that from our final answer, and our answer would just be x equals 2. All right, our last example, again, we have one quantity on the left, one quantity on the right. So we're going to go ahead and square both sides. This will leave us with 20 minus x equals x squared. And then again, we want to get everything onto one side of the equation. And again, this one we can factor. So to multiply to -20 and add up to positive x, we can do x plus 5 and x minus 4. So we get two answers applying our zero product property. X could be -5 or x could be 4. When we go and check those answers, again, this gives us our extraneous solution. This is not true. The square root of 25 is not equal to -5, it's +5. So that's going to be eliminated. And then we want to check 4 just to be sure. This would be square root of 16 equals 4, which is true. So our solution would be x equals 4. All right, so again, when you're solving these, it's important that you have one quantity on the left and one quantity on the right. So you might need to do a little bit of solving first and then square both sides. And then again, always check your final answers to make sure that they are not extraneous.